Hello, this is a representative from the NASA Jet Propulsion Laboratory. I am here today to talk to you about atmospheric spacecraft. Atmospheric spacecraft are designed for a relatively short mission to collect data about the atmosphere of a planet or satellite. One typically has a limited complement of spacecraft subs. For example, an atmospheric spacecraft may have no need for propulsion, subsystems, or attitude and articulation control system subsystems at all. It does require an electric power supply, which may simply be batteries, and telecommunications equipment for tracking and data relay. Its scientific instruments may take direct measurements of an atmosphere's composition, temperature, pressure, density, cloud content, and lightning. Typically, atmospheric spacecraft are carried to their destination by another spacecraft. Galileo carried its atmospheric probe on an impact trajectory with Jupiter in 1995. To prepare for atmospheric entry, Galileo increased its spin rate to stabilize the probe's attitude for atmospheric entry. After probe release, Galileo then maneuvered to change from an impact trajectory to a Jupiter Orbit Insertion trajectory. An aeroshell protected the probe from the thousands of degrees of heat created by atmospheric compression during atmospheric entry. Then parachutes deployed after the aeroshell was jettisoned. The probe completed its mission on battery power, and the orbiter relayed the data to Earth. The Pioneer 13 Venus Multiprobe Mission deployed 4 atmospheric probes that returned data during descent into the Venusian atmosphere in 1978. Each probe was designed to survive the extreme heat and pressure of Venus's atmosphere and to make measurements of the atmosphere during its 55-minute descent through an altitude range of 60 to 90 kilometers. All 4 probes transmitted data to Earth via the tracking and data relay satellites, which were used to acquire tracking data for the main spacecraft and the 4 probes. These atmospheric probes were jettisoned from Pioneer 13 prior to its own atmospheric probe and Venus lander deployments 2 weeks after the launch of Pioneer Venus. Each probe had made several revolutions around the Sun, bringing them into a trajectory that intersected Venus in early October 1978. At closest approach, the probes were each placed on a suborbital trajectory that took them through the upper atmosphere at an entry angle of 64 degrees and an entry speed of 11 kilometers per second, approximately 5 minutes before entry. The telemetry data rate increased to a maximum of 150 bits per second, as the antenna pointed directly at Earth. During the 55-minute duration of the probe's atmospheric transmission, the following measurements were made: electron concentrations, atmospheric gases, aerosols, cloud properties, temperature, and pressure. At an altitude of 60 kilometers, the atmospheric probes separated from their aero surfaces and a parachute was deployed. 2. Decelerate the probe for entry into the atmosphere. Each probe was equipped with a 300-watt transmitter and high-gain antenna to facilitate communications with Earth. A series of 5 back-to-back experiments was conducted during the 55-minute atmospheric transmission period. First, plasma probes measured the electron concentration, temperature, and composition of the ionospheric plasma. Next, gas chromatographs identified and quantified the constituents of the atmosphere. Then gas cells measured atmospheric constituents and aerosols in situ. Following that, cloud particle size and liquid water content were determined by impactors and a filter photometer. Finally, lightning was detected by an electric field sensor. Balloon packages are atmospheric probes designed for suspension from a buoyant gas bag to float and travel with the wind. The Soviet Vega 1 and Vega 2 missions to Comet Halley in 1986 deployed atmospheric balloons in Venus atmosphere en route to the comet. DSN tracked the instrumented balloons to investigate winds in the Venusian atmosphere. The Vega 1 balloon transmitted data for 57 minutes, during which it fell 12 kilometers through the atmosphere from 56 to 68 kilometers altitude. The Vega 2 balloon transmitted data for 45 minutes, during which it fell 9 kilometers through the atmosphere from 61 to 70 kilometers altitude. Both balloons were released from the spacecraft by means of a small rocket motor and a parachute. The balloon's float was constructed of a thin nylon film. A gas lighter than the surrounding atmosphere would have floated the balloon to the upper atmosphere, where it was designed to burst at an altitude of approximately 70 kilometers. A radioisotope heater provided electrical power to the balloon electronics. A telemetry package aboard the balloon transmitted data via a 169 MHz radio to the tracking stations of the DSN. Data consisted of atmospheric pressure, temperature, humidity, wind velocity, and vertical displacement. Other current and future atmospheric spacecraft include atmospheric probes carried by the European Space Agency, ExoMars Rosalind Franklin rover mission to Mars. The Trace Gas Orbiter will study the Martian atmosphere, while the rover will search for signs of past or present life on the surface. An atmospheric probe carried by NASA's Dragonfly spacecraft to Titan. Dragonfly will study prebiotic chemical processes on Titan and characterize the Moon in the atmosphere. An atmospheric probe carried by NASA's Da Vinci Plus spacecraft to Venus. Da Vinci will study the Venusian atmosphere and the formation of the planet S clouds, while the Plus probe will measure the chemical properties and dynamics of the atmosphere and clouds during descent. Currently, there are no plans to land a probe on Venus, but in 2023, NASA selected 2 missions for further development that could land a probe on Venus in the next decade. Informal plans for other kinds of atmospheric spacecraft include battery-powered instrumented airplanes and balloons for investigations in the atmospheres of Mars and Titan. Balloons are particularly attractive for future atmospheric missions because they can carry more scientific instruments than spacecraft of comparable mass. They are also less expensive and simpler to design and build because they do not have propulsion or attitude control systems. Atmospheric spacecraft offer unique opportunities to explore planetary atmospheres and search for life elsewhere in the universe. Although most atmospheric spacecraft have been to Venus, scientists hope to explore other atmospheres such as those of Mars, Titan, and the gas giants in the near future. This has been your host from NASA's Jet Propulsion Laboratory. Thanks for watching this video. If you like this video, give it a thumbs up and share it with your friends. And don't forget to subscribe for more videos like this one.